we know that Bowen ratio is basically ratio of sensible heat and latent heat. So beta is the Bowen ratio, H divided by LE. So we can divide these two equations. So here we can reverse the denominator here for ease of calculation. And now you can see that we can divide. The only thing important to know is KH and K nu, both are identical. So we can cancel these as well to get delta T over delta E times gamma, which is the psychometric constant, is our Bowen ratio. So if we have Bowen ratio, then we can compute latent heat in our energy budget. So we can substitute H from this equation. So that will be net radiation is equal to latent heat times beta plus latent heat plus ground heat flux. And we can come to this equation, which is the latent heat. So if we have latent heat, we can convert it in watts per meter square or joules per second per meter square. We can convert into millimeter. And if we divide this with the latent heat of vaporization of water, we will get our evaporation. So latent heat of vaporization, we know that it's a constant, which is 2,500 kilojoules per kg. Right? And then in energy balance, we can extend when we have different surfaces. So the energy will be stored in those surfaces such as delta S is the heat storage and delta A is the advection of heat, which is horizontal movement of heat with the air. There can be other storages as well. For example, if we are looking into the plants, we know that plants, they perform photosynthesis to produce their food. So they are storing chemical energy in their leaves and stems, depending upon, even roots, depending upon the nature of the plant. So that is the chemical change of chemical energy using this surface energy. Because remember, photosynthesis happens in the presence of radiation, the sunlight, in natural environments, right? So now what we can do is we can look into a strategy, how to read surface energy balance vis-a-vis change of the surfaces. For example, to simplify, we have put here 3 conditions. So in first case, we have a very mild water stress. Then in this middle, we don't have any stress, rather the water is being supplied through artificial irrigation. Artificially, so that is the irrigation. So, and then we have very dry conditions. So in this case, latent heat is equal. First of all, you can see the intensity of net radiation. That is same, almost the same magnitude for all these conditions. And ground heat flux is also same, though when we have very dry conditions, the ground heat flux will be a bit more, right? What is being changed? The 2 things, latent heat and sensible heat. And that makes sense because there will be evaporation and different amounts of evaporation in different conditions. So we will have different amounts of latent heats and contribution or sensible heats. So we will have different contributions of these 2 latent heats and the sensible heat in our net radiation. So if we have very mild water stress, canopy of temperature will be greater than air temperature, but still we will have evaporation and we will have sensible heat, and these two are equal. And since these two are equal, it means that we will have a Bowen ratio of 1, right? So if we go into the no water stress state, so latent heat will be more than sensible heat. Canopy temperature will be less than air temperature. So when we see this type of condition, that we have a lot of evapotranspiration, or in other words, we have a good amount of latent heat, whereas we have negative sensible heat, it means that there is more evaporation, and hence we will have Bowen ratio less than 1, and in some instances it will be negative, in negative, in case of this kind of situation, which is well-watered system. And the Bowen ratio is increasing when we are going to dry conditions. And if we go to the very dry conditions, we will see that there will be less evapotranspiration and lot of sensible heat. So the surface temperature is much greater than the air temperature in this case. And in the dry conditions, then if you look into the natural habitats, you will find in these type of conditions, if we have vegetation, it has evolved in a way that it needs very less water because there is low evapotranspiration. So they will not be able to utilize sun energy to produce their food. So they have changed their phenologies in a case. So this is how you will be looking into interaction of various surfaces with the surface energy balance in the boundary